Some chemical reactions don't just release heat or change substances, they move electric charge. When a battery powers a phone or a car starts with a spark, chemistry is doing something remarkable. It is turning chemical energy directly into electricity. This ability to convert matter into moving charge is what makes electrochemistry one of the most powerful ideas in modern science. This is the Learning Studio, where chemistry is explained as a system that connects invisible processes to everyday technology. And after understanding equilibrium and how reactions shift under different conditions, the next logical step is to see how chemical reactions can be controlled to produce electrical energy. Most people think electricity comes only from power plants and wires, but in reality, it often begins with chemical reactions. For example, when you insert a battery into a device, nothing is burning and nothing is spinning. Instead, chemical reactions inside the battery push electrons through a circuit, creating an electric current that powers the device. At the atomic level, the mechanism is precise. Electrochemical reactions involve the transfer of electrons from one substance to another. When a substance loses electrons, it is oxidized. When a substance gains electrons, it is reduced. By separating these two processes and forcing electrons to travel through an external circuit, chemical energy is converted into electrical energy. This controlled electron flow is the heart of electrochemistry. This idea was first demonstrated by Alessandro Volta, who built the first electric battery by stacking different metals separated by an electrolyte. His work proved that electricity could be generated chemically rather than mechanically, laying the foundation for modern batteries. Later, Michael Faraday showed that the amount of electricity produced is directly related to the amount of chemical change occurring, turning electrochemistry into a quantitative science governed by laws rather than curiosity. As understanding deepened, electrochemistry expanded far beyond simple batteries. It explained corrosion and rusting, electroplating and metal refining, fuel cells, sensors, and modern energy storage systems. The same principles that move electrons in a small battery now power electric vehicles, store renewable energy, and enable portable electronics. Electrochemistry also plays a critical role in biology. Nerve signals, muscle contractions, and even thought itself depend on controlled electrochemical processes inside cells. Life uses electrochemistry constantly, proving that electricity is not just an industrial phenomenon, but a fundamental feature of chemistry. And once we understand how chemistry can generate and control electricity, the next question naturally follows. If electrical forces and chemical structure are so closely linked, then how can chemistry be used to precisely identify and measure substances? That question takes us directly into the next episode, where we explore analytical chemistry and how scientists see the invisible using precise measurements.